Hi, today we are going to cover lesson 1.4, angle measure. So you'll be able to name angles and the parts of an angle, measure and classify angles, and use congruent angles and the bisector of an angle to solve. We're going to go ahead and skip this 5-minute check again and move on to our vocab. So we have a bunch of new vocab. These are ray, opposite rays, angle, side, vertex, interior, exterior, degree, right angle, acute angle, obtuse angle, and angle bisector. So we're going to jump right in to measuring and classifying angles. A ray is a part of a line. It has one end point and extends indefinitely in one direction. So in this case, M is our end point and it extends indefinitely in this direction. Rays are named by stating the end point first and then the other point on the ray. So the ray shown, it cannot be named OM because that would be a ray going this way instead. Because O is not the end point of the ray. So we name it either ray MO or ray MP. Notice, like segments and lines, we put a label on top. This time it is a ray symbol with one arrow. If you choose a point on a line, that point determines exactly two rays called opposite rays. These form a line. So an opposite ray is a line. Since both rays share a common endpoint, opposite rays are collinear. So J is their common endpoint here. We have JK and JH are rays that are opposite, and they are collinear, forming a line. An angle is formed by two non-collinear rays, so they do not form a line, that have a common endpoint. The common endpoint is called the vertex, so in this case, our common endpoint is X. They also have sides, which are our rays. So our rays here form our sides. So ray XY and ray XZ are our rays that are the sides of our angle. Notice the vertex is always the first point that we talk about when naming our sides. Next, when naming angles using 3 letters, the vertex must be second of the 3 letters. You can name an angle using a single letter only when there is exactly one angle located at that vertex. So in this case, there is only one angle here, which means we can name it angle X. The angle shown can also be named using a number. That number has to be between the two sides, so we can call this angle 3. And then notice that center vertex point is the second letter or the middle one when naming our ray, so we can also name it angle YXZ and angle ZXY. We can just flip those 2 letters. So that's 4 different ways to name the same angle. It's all talking about the same thing. Last thing, when we name an angle, we must put that angle symbol out front so we know we're talking about an angle, not a plane, not a line, not a point, not a triangle, just an angle. All right. Next thing on here, an angle divides a plane into 3 distinct parts. We have the points on the line, so Q, M, and N are on our line. We have the points on the interior, so anything inside are points on the interior, so S and R. And then there's also points on the exterior, P and O are on the outside. So if we had an angle that is just slightly smaller than 180 degrees, this up here is still considered the interior, and this is still considered the exterior. Okay? This would close in like this. So, part A of this slide, we need to name all angles that have B as the vertex. So first we locate B. We're not going to include straight angles in this. So we are only going to have 4 angles. We're going to have angle here. We're going to have this angle. We're going to have this angle. And then one more, this angle. Now, some of these have up to 5 ways to label them. On your homework, I'm only going to ask you to do one of the 5 or 4 or 3 or 2 ways to label it. But on this, I'm going to show you how many different ways there actually are. So we're going to name all the angles that have that vertex. So I'm going to start with the angle that I outlined in pink. The first way I can label it is angle G, B, E. Similarly, I can name it angle G, B, F. Notice my vertex point will always be the one in the center here. I can also label this the opposite of each of these, angle F, B, G, and angle F, E, B, G. And lastly, I can name it angle 5, because that is the number right here in the center. I cannot name it angle B because there are 4 different angles that also share that vertex. Alright, the red angle, only has 2 different ways to name it. We have angle GBA and angle ABG. Both correct. On your homework, you'd only have to choose one. The green outlined angle has 3 ways to name it. Angle ABD and angle DBA, as well as angle 7. And the blue angle has 5 different ways as well. Angle DBE, angle DBF, the reverse of each of these, angle EBD, and angle FBD, and as well as angle 6. Okay? So a bunch of different ways. On your homework, you could just choose like this one, and this one, and that one, and this one. You don't have to write all of the different choices, although they are all correct. All right, now we're going to name the sides of angle 5. So the sides are rays. So we'll have 2 rays, starting with the end point or the vertex, and go from B to G. Starting with the end point again for the other side, we can go B to F. Now another correct answer for this one would be ray BE. Either one is fine, you don't have to write both. So our sides are rays, and there are 2 of them. And then another name for angle 6. We actually already named angle 6 a bunch of times. We'll see that over here. So I'm just going to copy that down here. And there are 4 other ways to write angle 6. Okay? That is this angle right here. So since we already did it, you can just put it right there. Alright, now we're going to move on to angle measure. Angles are measured in units called degrees. The degree results from dividing the distance around a circle into 360 parts. So 1 degree is 1/360th of a turn around a circle, shown by this picture here. Okay? To measure an angle, you can use a protractor. Angle DEF, right down here, is a 50-degree angle. We say that the degree measure of angle DEF is 50, or we can use the shorthand fancy M, which stands for measure of angle DEF equals 50. Now I do want to let you know In class, we aren't going to be using protractors very often, mostly just on this notes slides. But it's still good to know. We're going to assume that our angles are not drawn to scale, and we'll just solve using algebra. But here's a section on protractors. Another thing I want to point out, when you say angle DEF, this is naming the angle. When you put that fancy M in front of it, measure of angle DEF equals 50, this is saying how many degrees the angle is. So make sure you make that differentiation. Okay? So down here, we're going to zoom in. The protractor has two scales running from 0 to 180 degrees in opposite directions. Place the center point of the protractor on the vertex of your angle and align the 0 on either side of the scale with one side of the angle. Since ED is aligned with 0 on the inner scale, use the inner scale here to find that ray EF intersects the scale at 50 degrees. All right. Now we're going to classify angles. Angles that are 90 degrees are called right angles. You can also tell they're 90 because of this little box here. The symbol means it's 90 degrees. Acute angles are anything smaller than 90 degrees, and I would also add they are bigger than 0 degrees. And obtuse is any angle that is bigger than 90 degrees but less than 180. So it's not a straight line and it's not a right angle, it's anything between those. So we are going to find the measure of angle T, Y, V and classify it as right, acute, or obtuse. So first of all, let's find where T, Y, V is. And then I'm going to extend this line, line TX, to show a point. So line TX is a straight angle. That means it equals 180 degrees. And we know that this angle VYX equals 90 degrees. So if we subtract those, we should be left with this leftover portion here, which is what we want to find. So 180 minus 90 equals 90 degrees. That means the measure, make sure you're labeling it correctly, of angle TYV equals 90 degrees, and that is a right angle. On here, go ahead, find the measure of WYT. I like to trace it out to find what my angle is and classify it as acute, right, or obtuse. Now, they went ahead and told us what it is. It is 130. I know that's obtuse because it's between 90 and 180. So the measure of angle WYT is 130 degrees. This one, next one, they also told us the degrees. We have angle TYU. They tell us it's 45. So I know that's acute. Oops, that's acute. And I can say the measure of angle TYU is equal to 45 degrees. Easy enough. Last little new information has to do with bisecting. So if you recall, we talked about segment bisecting, cuts it in half and makes the two pieces congruent. If a ray divides an angle into two congruent angles, it is called an angle bisector. So we can do the same thing with angle bisectors as we did with segment bisectors. So if YW is the angle bisector of our angle XYZ, then our W point must be in the interior of our angle, and our subangles, our part angles, XYW and WYZ, must be congruent to each other. And you see right here with our hash marks, the red semicircles, They are congruent, and they also label them both as 80 degrees. So just with segments, when a line segment or ray divides an angle into smaller angles, the sum of the measures of the smaller angles equals the measure of the largest angle. So in this figure, the measure of x, y, w plus the measure of w, y, z equals the measure of x, y, z. It's like our segment addition postulate, but now it's with angles. We'll skip this one and we'll go to our last problem. In the figure, we have KJ and KM are opposite rays. That means they form a straight line. We don't want to worry about that right this second. KN bisects angle JKL. That means it cuts it in half. We know that these are now congruent, which means they equal each other. So if JKN is equal to 8x minus 13 and NKL is equal to 6x plus 11, they are congruent, so they equal. So we can go ahead and solve for x by equaling them to each other. And then plug our x back in for what we need to solve. So I got x equals 12. I need to find the measure of angle JKN. So I plug that back into JKN. Honestly, it doesn't matter which one I plug it back into because they equal each other, but I'm going to do the one that is specifically asked for. So 8 times 12 minus 13. 8 times 12 is 96. Minus 13, so our angle measure is 83 degrees. Now a little bonus here. If this angle measure is 83 degrees, then because they're congruent, this angle measure is 83 degrees. A little peek into the future problems we're going to do. This guy, we will eventually have to find. It's not really that bad. We know that this angle here is 180 degrees. So we can take 180 equals 83 plus 83 plus, we don't know yet, so we'll call it x plus x. And then you can go ahead and solve for x. This one's going to be pretty obviously not drawn to scale. We get 14 degrees is the solution for this angle here. So that's a little bonus. We didn't actually have to do that. You will in the future. But if you can think through that and get that now, that's really awesome. Have a great